Hi, today I'm going to talk about how to think about the architecture and the design when we build a app like a mobile app or a web app. Now, if you think about a uh, app like this, for example, consider a app that manage doctor appointments. The app will let you see the available doctors, make an appointment, maybe come and later look at that appointment or change that appointment. This app and most of the other apps, what they do is they receive some data or bits from the user. Uh, it may store it, it may read it back, it may do some processing, it may send it to some other places. That's what these apps do. But the architecture we build are a lot more complicated than that. There's a lot of other things going on. Why? So the main reason is that when we build an app like this, our goal is not to get it just working. We want to be able to change this app when the world changes or when our requirement change. Now, to be able to do that, we developers need to understand the code so that we can change and evolve that code. Now, a lot of the architecture considerations of a design like this are built to make it easier for humans to understand and change the code. So this come, as I said, so that some of these considerations are we need to change the code. Uh, and we try to make the code modular. Modular means it break the system and the code to parts that are independent. We can't make them completely independent, but we at least make the dependencies between different modules less. Also, we try to reuse things. Right? We try to, for example, we try to use a database instead of trying to rewrite how to store the data. Also, there are security considerations. For example, if we take a mobile app, what happened in the user's uh, mobile app cannot be fully uh, trusted when we design the architecture. So all these considerations come into play. Now, based on these considerations, we have built a series of concepts. For example, database, front end, back end services. We'll talk through most of these today. So these concepts give us three advantages. First is that these are best practices so that every developer or every architect don't have to recreate this. Second is this let us build tools, libraries that can be reused. And the third, these concepts make it easier for us to talk to each other about the architecture. For example, if I want to, but I'm moving away and somebody else is going to take over, and I want to explain to him how it works, these concepts make it easier to understand. Everybody knows what the database is, what the service is, etc. So, so when we design, we are trying to use this set of well understood concepts to build the architecture. Okay. So as an example, let's use this doctor appointment app that we discussed earlier. Now, if you think about let's say this is a web app, user talk to the app. Using HTML, you can describe a web page and the browser will show that web page. So user will talk to this app and the app will send him HTML, him or her, and he will see that, then he do some things, the app will respond, etc. Now, of course, you can write everything in this app and you can handle data stores as well. However, one of these concepts that we have identified is a database, because we don't want to implement data storing, data querying every time. So it is very common for us to use a database and hand over the data storage function to the database. Now, that means this other part, rest of the app, need to handle talking to the user, generating HTML, etc., and also processing. One thing we learn after some time is that putting this uh, code to handle the front end and the code to handle the business logic. So we usually use the term the business logic to mean processing. For example, in the case of doctor appointment, the business logic will look at who are the available doctors, their available time, and accordingly give a appointment based on that and maybe other rules. So that part, that business logic. So usually we don't like to put both the front end code and back end the business logic together. Here we are trying to use this idea of modular. We are trying to break our code or the design into different parts so that they can operate with each other, and we try to identify how they interact with each other very clearly. We call this kind of interaction, how the interaction happen, an interface. The interface decide how these two things talk. So it's a good practice to break the business logic and the UI code to two parts. So now we have three parts. This is called, we call this 3T architecture. The UI part is called presentation layer. The business logic part is called application layer or service layer. And you have the database. So what is a service? The service is something that receive a request. Usually this request come as a JSON. You can read about JSON. I won't try to explain what JSON is. It's a way of representing data. The service usually receive a request as a JSON, do some processing, and send a result as a JSON. So you can use XML. There are other ways of representing data. You can use those as well. But let's stick to JSON. Okay. So the service get a request, do some work, send a response. So the application layer can have one service or many services. Again, each service try to, it's another level of grouping things. We try to make each service independent. Of course, they may have to talk to each other, but it's a good practice to try to make them independent. So if we go back to our example, when a user come into the doctor appointment app, when the first page loads, it'll go now. Earlier, this design, it will directly go to the database. Now it will talk to a service and say, give me the available doctors. And the service will go to the database, get the available doctors, and send the list of available doctors to the front end. And the front end might show it to the users. User will select which doctor, etc. And then send another service call saying, book this doctor. It will talk to the database, do the necessary data manipulation, and book that doctor, and so on and so forth. So this next picture goes into show a more realistic system. I only explained the high level idea yet. This is how a real system will look like. So there's one more idea we need to understand. When we draw the front end, when we generate the front end, there are three options. What I explained so far, which is that user talk to a browser, the browser send a request, and the server side generate the UI to be seen, send it back, and then user do something, then another HTML request goes back and forth. This is called server-side web app. That is because all the HTML is generated at the server side, and every step is done at the server side. So now, if we talk through the earlier case, the user asks, and the rendering request comes, then it will forget these layers for now. It will talk to the service, go to the database, and send a response back. There's something called client-side rendering. So here what happens is when the app is open, on the first request, we download the HTML. But after that, we don't change that. We don't redraw the HTML. Instead, this JavaScript code running here will talk to the server. For example, in our case, for the appointment app, it do a service call saying, give me the doctors. Now, here, this service code directly going through these things, but talking to the server, the response comes, and you update the picture. Now, comparatively here the request goes, this one do, and this part is HTML. This is HTML. And this here, it is a service call, usually HTTP and JSON. Here, the JSON call directly goes here, get the results, come back, and the UI changes. The third one is a mobile app. It works very similar to this client-side rendering case. Again, the API calls happen. So when you build an app, you can choose to do. So the one choice is whether you do the mobile app or the web app or the both. Another choice is, do you want to do a server-side web app or a client-side web app? So these are choices based on different situations, different things work better. So if you Google, you will find a lot of information. Okay, now this architecture shows few more other things that are usually play a role in your architecture, this more realistic architecture. So one is the firewall. The firewall, usually this, what is inside this run inside the applications organization. For example, this, if it is Google running this application, it's run inside Google. This part of the system uses machine. So we put the firewall to stop some of the attacks. There are different kind of firewalls, but usually we put a web application firewall to stop SQL injection attacks, cross-site scripting. You can Google for those. I won't try to explain them right now. Now, if you consider these cases, this case, we do HTML call here, but then HTML call do this service call here. That means is that your service is invoked by a code running inside your organization. However, in these two cases, your service here is invoked by a code running outside your organization. Now, for the second case, there are a lot of things you need to worry about. For example, you need to worry about security. You want to make sure only the allowed people can talk to your service. And you want to make sure they can do only the allowed things. And you want to also, for example, keep track of who is called. To handle these kind of details, you use API management. It's a tool, it's a product that you can add. Basically, what you do is you take your services, you configure them with the API manager. We say that they become APIs. Then you ask the user to use it come through the API management and use your service. We already know about database, we know about services. Then one other thing is BFF. This is called backend for frontend. Uh, this we use this when API calls come from this side and the services running here, they don't match exactly. For example, if you support both the web app, client-side web app, and the mobile app, and you may have some other apps. For example, if you take Netflix, for each device, there are different apps. Now, these apps may behave differently. Their API may be different, and there may be mismatch from those API calls that's easy for them to call and these services. So then we put this layer in between to translate and make sure they fit with each other. You don't have to do a BFF, but that's another common thing people use. Last part, most applications handle users. So that means the user he can log in, he can look at things. For example, if you look at the doctor appointment app, you can do a version there are no user, anybody can come and pay and maybe and make an appointment. Or where I can create an account, and when I come back, I can see my all appointments, etc. Now, if your app have users, then you need to manage this. To do that, we usually use something called CIAM, Client Identity and Access Management. Uh, Of course, you can write code to do this, just like you won't write a database yourself. It's not a good idea to try to write this again because there are a lot of features. The simple version is very easy, but for example, if you have users, you need password reset. You need to support new security attacks, rather defend against new security attacks, support new security protocols. Your initial work lead to a lot of other works. But if you use a CIAM, it will handle most of these complexities. Now to recap, so there are concepts we have identified. And we discuss when we build the app, some of what concepts that are available. For example, we use a database and we extract out the code to draw draw the draw the web app and code to do the business logic or the processing into two parts, and we call that 3T architecture: presentation, application, and database. Then this presentation part, there are two ways to implement: server-side web app or client-side web app, or you might do a mobile app too. And so it still is a 3T. You can think it as the 3T architecture. You have services, database, and to expose these services outside your network, you would use API management to make it easier. You can also write code to do that, but that's a lot of work. And also, if you have users, you will use CIA. We walk through on a lot of decisions, a lot of ideas involved in building app. Some of those I explained, some of those I didn't explain in a lot of detail because it takes time, but you can Google. So my idea was to connect the main ideas. Hope this was useful. Looking forward to talk to you again soon.